Welcome to a new video by Wiskunne English. In this video we're going to solve quadratic equations in the set of complex numbers. We're going to make two exercises and we start right away with the first exercise. Z to the power of 2 plus 2 times z plus 5 is equal to 0. Now we're going to solve this using the discriminant. Formula for discriminant is b to the power of 2 minus 4 multiplied with a and c. So we get 4 minus 4 multiplied with 1 multiplied with 5, we get minus 16. So discriminant is minus 16. We need the square root of the discriminant, so we get plus or minus 4i. It's best to pick one, so plus or minus. I always pick the positive one. It doesn't matter, but I always pick the positive one. Why doesn't it matter? Because z1, so the first solution, is minus b plus the square root of d divided by 2 times a. And the second solution is minus b minus square root of d divided by 2 times a. Now, if you take minus 4i, you get minus 4i plus 4i. If you take plus 4i, you get plus 4i minus 4i. So you see, you get the same solutions. Now we fill in, we get minus 2 plus 4i divided by 2. So z1 is equal to minus 2 plus 4i divided by 2. And z2, second solution, is equal to minus 2 minus 4i divided by 2. So we get z1 is equal to minus 1 plus 2i. z2 is equal to minus 1 minus 2i. So we solved it with the discriminant. Then we had a simple discriminant minus 16. In the next exercise, the discriminant won't be a real number. It will be a complex number. And then we have another solution. So now, next example. We have z to the power of 2 plus z minus 1 plus I is equal to 0. I'm going to use the discriminant. So in this exercise I'm going to use the discriminant as well. We have b to the power of 2 minus 4 times a multiplied with c. So we get 1 minus 4 multiplied with I multiplied with minus 1 plus I. So we get 1 minus minus becomes plus. So we get plus 4i. I to the power of 2 is minus 1, so we get minus 4. So we get that the discriminant is equal to minus 3 plus 4i. Now, this is a problem because the square root becomes minus 3 plus 4i to the power of 0.5 or the square root of minus 3 plus 4i. Now, we can solve this because this is equal to a complex number. So we can say that a plus bi is equal to the square root of minus 3 plus 4i. Or we can say that a plus bi to the power of 2 is equal to minus 3 plus 4i. Now we can calculate this. So we get a to the power of 2 plus 2 times a bi minus b to the power of 2 is equal to minus 3 plus 4i. So we have this. Now we see this is real, so it must be equal to minus 3. This is the imaginary part, so this must be equal to 4i. So we have a system of equations. We have a to the power of 2 minus b to the power of 2 is equal to minus 3. And we have 2 times abi is equal to 4i. Now we can remove here some things. We can divide by 2 and we can remove the I. So we get a to the power of 2 minus b to the power of 2 is equal to minus 3. And we get ab is equal to 2. Now we can use the substitution method. So we can say b is equal to 2 divided by a. So next step is a to the power of 2 minus b to the power of 2 is minus 3, and b is equal to 2 divided by a. Now I'm going to substitute this b by 2 divided by a. So we get a to the power of 2 minus 4 divided by a to the power of 2 is equal to minus 3. And then we have b is equal to 2 divided by a. Now I'm going to multiply the first equation with a to the power of 2. So I have a to the power of 4 minus 4 is equal to minus 3 multiplied with a to the power of 2. And b is equal to 2 divided by a. Now everything to the left side, so we get a to the power of 4 plus 3 multiplied with a to the power of 2 minus 4 is equal to 0. b is equal to 2 divided by a. Now I'm going to say, for instance, u is equal to a to the power of 2. Then I have a quadratic equation. So we have u to the power of 2 plus 3u minus 4 is equal to 0. b is equal to 2 divided by a. I can use the sum and product method. So the sum is minus b divided by a is minus 3, and product is minus 4. So I have minus 4 and 1. So minus 4 and 1. So a to the power of 2 is equal to minus 4, or a to the power of 2 is equal to 1. Now a is a real number, so a to the power of 2 equal to minus 4. That's not correct. There's not an a that can be done to the power of 2 and that it is equal to minus 4. So we're going to remove that solution. So we have a to the power of 2 is equal to 1. So a is equal to 1, or a is equal to minus 1. And if a is equal to 1, b is equal to 2. And if a is equal to minus 1, b is equal to minus 2. So you see we have, for the square root of the discriminant, we have plus minus 1 plus 2y. So you see again plus minus. Now the equation was I to the multiplied with z to the power of 2 plus z minus 1 plus I is equal to 0. So now we have again z1 is equal to minus b plus the square root of d divided by 2 times a, and z2 is equal to minus b minus the square root of d divided by 2 times a. So we get minus 1 plus 2i divided by 2i is equal to z1, and z2 is equal to minus 1 minus 2i divided by 2i. So we get 2i divided by 2i, and here we get, so the v is or, z2 is equal to minus 2i divided by 2i. So here we get 1, because 2i divided by 2i is 1. Here we're going to multiply the numerator and the denominator with I. So we get minus 2i plus 2 divided by minus 2. So we get z1 is equal to 1, and z2 is equal to minus 1 plus I. So you see, if the discriminant is a complex number, it's a lot of calculations, and then you get this. I hope you enjoyed this video. Please like the video and subscribe to the channel.